the evolution in clinker cooling, the newly developed Claudius Peters Etta cooler, the most technologically advanced clinker cooler in the world today. The past decade has seen various developments and innovations in clinker cooler design. The cooler is one of the most important units in the total kiln process. Claudius Peters specialists analysed the advantages and disadvantages of all systems available on the market. Together with our clients, we consequently developed a completely new clinker cooling system. The 4-year Etta cooler development period demonstrates our effort to provide the industry with a well-engineered design. Strictly modular is one major principle of the new Etta cooler. The total cooler is built out of basic modules for a capacity range of up to 15,000 tons per day. Let's have a look at the design of the modules. The front end of the cooler is equipped with a static inlet, the high-efficiency HE module. It achieves an optimal clinker distribution over the width as well as the quick quenching of the clinker. The inclined, totally flat HE module extends from the kiln drop point to the transport lanes. It is aerated via independent zones. The slot plates are fastened by a single bolt. The transition from the static area to the movable lanes is accomplished by the first Etta cooler module with cross-sealing under the HE module. The moving, walking lanes require a unique seal design. The very special cross-seal inside and between each lane has been designed to ensure that the cooler is totally riddling-free. It uses a transport system that is unique to any of the present coolers, the walking floor system. The Etta cooler consists of parallel transport lanes which are moved together in the direction of the clinker transport and retracted individually or in groups. The individual cooler length and width for different clinker capacities will be built out of just 2 main module lengths. The width is variable by the number of lanes. Depending on the required throughput capacity, a corresponding number of parallel transport lanes are installed side by side, each supported on independent heavy-duty rollers. Independent lane movement, parallel, individually driven, aerated lanes. The slots for the air supply are integrated in the transport lane bottom by utilizing the Malden grate plate principle. The cooling air can penetrate over the entire bottom without any large dead areas. The Etta cooler has 1 or 2 hydraulic cylinder drive modules, depending on the capacity. Each lane drive is connected to one hydraulic unit, the power pack. The hydraulic cylinders with integrated continuous measuring system dedicated to each transport lane enable an adjustable long lane stroke. The speed of each lane can also be adjusted to the requirements. The last module of the cooler is the transition to the clinker crusher. This module is built out of the 2 standard units of different lengths. The active width of the crusher corresponds to the width of the Etta cooler. During the forward stroke, the lanes convey the clinker to the grizzly chute for screening the fine pieces and guiding the oversize directly to the crusher. Each Etta cooler module is an independent, pre-assembled unit. After the workshop assembly, the cooler has been disassembled into the 6 modules for shipment. The simple connection of the lanes and sidewalls allows for easy dismantling. It only takes 3 low-loader trucks to transport the entire Etta cooler to the site. The first unit is leaving the workshop in time on its way to the Ziegenthal cement plant. The plant is located in the north of Switzerland near the French and German border. The capacity of the kiln line is approximately 2,000 tons per day. Another major objective of the new concept is the time-saving method of installation. This is helped by simple foundations and less civil engineering work. The first Etta cooler, size 645, replaces an old reciprocating grate cooler. The modules are lifted, one after the other, onto the burner platform lowered down by the indoor crane onto the ground floor. The opening in the burner platform was only slightly larger than the modules, and a very precise job was required. Thanks to excellent teamwork, the modules were brought safely into the cooler building without any problem in an extraordinarily short time. On the cooler floor level, each module had to be moved on rollers exactly into its final position. An amazingly precise and professional job, and the time saved compared to an ordinary assembly was tremendous. The same procedure 6 times, and after only a few hours, all Etta cooler modules have been joined together again. Now the hydraulic piping and the electrical installation, as well as the refractory work, can start. A major part of the refractory has been reused. Here we can see the HE module with special horseshoe castable design and integrated air cannon nozzles. Finally, the whole lane bottom is filled with clinker for heat protection. After all the years of development, all the hard work, everyone looked forward to this great moment. Clinker cooling has evolved. The next generation of clinker cooler is born. The new Etta cooler fits perfectly into the existing cooler building. The cooling fans are located in the basement on both sides. The hydraulic cylinders are connected directly to the power pack, which is placed on the burner platform. The cooler upper part was reconditioned and reused. The upper side wall gives a view into the cooler through observation holes. The view into the cooler shows the unique movement of the clinker. For a clearer idea, here are some pictures of the test unit in the Claudius Peters Technical Centre. Forward stroke, 100% of the clinker moves forward. Backward stroke, only 20 to 25% is carried back. The higher transportability of the Etta cooler is not the only advantage. Even more valuable is the independent lane movement. The Etta cooler transport system actively influences the clinker conveying and distribution. For the first time in clinker cooler history, this virtually eliminates such problems as Red River. The hydraulic cylinders operate at just 2 to 3 stroke cycles per minute. None of the air chambers shows any riddling. A conveyor underneath the clinker cooler is no longer required. 100% clinker transport and cooling. The Claudius Peters Etta cooler makes use of the simple chamber aeration principle, the well-proven aeration concept. However, in contrast to reciprocating grate coolers, the Etta cooler allows airtight longitudinal chambers, which improves cooling at the critical side areas. Together with the operators of Holcim Ziegenthal, the Claudius Peters startup team quickly learnt how the cooler performs and how to set up the Etta cooler parameters to its optimum. It is the first cooler which can be adjusted and set up during operation with regard to the clinker distribution of the kiln discharge. The process data of the first months have proved an excellent cooling ability. Along with a high recuperation efficiency, the clinker is cooled down with a minimum of cooling air. The new Claudius Peters cooler is perfect for its purpose, to take the hot clinker delivered from any kiln for effective, efficient cooling. That's what ETA stands for. New levels of controllability, new levels of thermal efficiency, new levels of transportation efficiency, significantly lower wear, lowest possible profile, and modular, standardized design. Cooling, a most important part of the clinker producing process, has reached a new generation. The clinker at Ziegenthal is uniformly cold, and the heat has been utilized to the highest degree. The whole Etta cooler project, from its conception in 1999 to the startup in July 2004, is a story of perfect teamwork, resulting in the most technically advanced clinker cooler in the world today. Clinker cooling has evolved.